As the sun rises and when the world is still asleep, China is already moving. Cranes stretch toward the clouds. Trains cut through mountains like silver arrows. Bridges float across oceans where ships once ruled alone. In just a few decades, China has reshaped its land, its cities, and its future through mega projects so vast they can be seen from space and felt across the global economy. This is not just a story of concrete and steel. It is a story of vision, ambition, sacrifice, and machines built to challenge the limits of human engineering. Welcome to China's mega projects. China is home to more than 1.4 billion people. To move them, house them, and connect them, small thinking is not enough. In the late 20th century, China faced enormous challenges: overcrowded cities, slow transportation, rural isolation, economic imbalance. The solution was bold: build faster, build higher, build further. Mega projects became tools of transformation, turning villages into cities and distances into minutes. Every bridge, railway, and skyscraper would serve one purpose: connect the nation as one system. The Hong Kong-Zhuhai-Macau Bridge. Stretching 55 kilometers across the sea, this bridge is not just long, it is revolutionary. It crosses open ocean, shipping lanes, earthquake zones, typhoon paths, and it doesn't stop at bridges. Part of it dives underwater, becoming a tunnel beneath the sea. How it was built? Artificial islands were created from scratch. Tunnel sections were floated, sunk, and joined underwater. Construction continued despite waves, storms, and strong currents. New equipment used: giant floating cranes lifting sections heavier than warships, GPS-guided positioning systems accurate to centimeters, smart concrete designed to last over 120 years,
Check the load calculations here.
real-time stress
they look
sensors
stable.
embedded
Good.
inside
Update
the
the timeline.
structure. This bridge cut travel time from 3 hours to 45 minutes, changing trade, tourism, and daily life forever. Bridges above the clouds. In China's mountainous regions, bridges don't cross rivers, they cross empty air. The Beipanjiang Bridge, suspended hundreds of meters above a deep canyon, connects regions once separated by days of travel. Workers lived on cliffs. Materials were delivered by cable systems. One mistake could mean death. Yet the bridge stands, proof that even gravity can be negotiated. China has built the largest high-speed rail network in human history, over 40,000 kilometers. That is more than the rest of the world combined. The vision? To make every major city reachable within hours, not days. The reality? Trains traveling at 350 kilometers per hour, smoother than airplanes, quieter than highways. Engineering the impossible. High-speed rail is not just about trains, it is about precision. Tracks must be perfectly level, resistant to heat and cold, stable during earthquakes. New equipment used: giant tunnel boring machines the size of apartment buildings, automated track-laying trains installing kilometers per day, AI-based monitoring systems detecting millimeter-level track shifts, fixing bullet trains with self-diagnostic intelligence. China didn't just expand outward, it built upward. Shanghai Tower. At 632 meters, it is one of the tallest buildings on Earth. Its twisted design reduces wind force by 24%, saves massive energy, allows natural airflow. How it was built? A core built like a concrete spine, floors added using self-climbing platforms, construction cranes that climbed with the building. Advanced equipment, ultra-high pressure concrete pumps pushing material 600 meters up, robotic welding arms at extreme heights, double-layer smart glass systems for insulation, maglev elevators moving diagonally and vertically.
Right.
These skyscrapers are not
What about the right
offices,
side block?
they are
It looks
vertical
stable.
cities with malls, gardens, transport hubs, and energy systems. Mega projects are powered by machines never seen before. Construction giants, cranes lifting over 20,000 tons, robots welding steel day and night, AI systems coordinating thousands of workers. Digital construction. China now builds virtually first. Entire projects simulated in 3D. Stress, weather, and time modeled in advance. Errors solved before construction begins.
These
This
projections show a
reduces
20%
cost,
increase in
risk,
efficiency.
construction
Let's optimize
time.
the distribution network.
Behind the
The
machines are
integration looks
people,
seamless from this vantage.
engineers
Agreed.
away from
Let's adjust the
families
commercial
for
sector
months,
density.
I'll model the
workers
traffic
living in temporary cities, families watching projects rise on video calls. On weekends,
Hi,
some
everyone.
travel
How's it
home
going?
by bullet
We're good.
train,
Just missing you.
others rest
World's
in
busy, but
camps
we're
near
okay. Be
sites.
safe out there.
Many dream of
We
the
miss you
day they
both
can
so
say,
much.
I helped
you too,
build
buddy.
that. These
When are you coming
projects
home?
are built with sweat, hope, and pride. China's mega projects are not just national achievements. They influence global trade, international engineering standards, infrastructure across Asia, Africa, and Europe. They show what happens when planning, technology, and scale move together. As night falls, trains still run. Bridges glow above dark water. Skyscrapers touch the stars. China is not finished
Alert on
building.
Sector 7, bridge integrity drop.
China's
Copy.
mega
Rerouting
projects
traffic
are
now.
engineered
Confirm, sending drone for
years
visual.
before construction begins by teams of civil engineers, structural designers, geologists, and AI planners working together in massive digital labs. These engineers are the invisible architects of the future.
Confirm. Grid is
Every
stable.
project
Pushing the
begins
update. Watch
with the
for anomalies.
ground itself.
Let's begin with soil strength and
Engineers
rock layers.
study
Earthquake
soil
fault lines are a key
strength,
concern.
rock
And wind
layers,
patterns with ocean
earthquake
currents, plus
fault
temperature
lines,
extremes.
wind patterns, ocean currents, temperature extremes. For bridges, underwater robots scan the seabed. For railways, drones map mountains and valleys. For skyscrapers, wind tunnels simulate storms decades into the future. Nothing is guessed. Everything is calculated. China uses BIM, Building Information Modeling. This means the entire bridge, railway, or skyscraper is built digitally first. Every bolt, cable, and beam is simulated. Stress, weight, vibration, and aging are tested virtually. If a problem appears in the simulation, it is fixed before real construction begins. Engineers can already see where cracks might form in 50 years, how wind will twist a tower, how trains will
This load
behave at
calculation here
full
needs adjustment.
speed.
Agreed, we
The
should increase the beam
real-world
size.
construction
Yes, and
becomes
update
the
the timeline.
final
I'll check
step,
the specs.
not
各
the
位同事，
first.
这是我们最新的城市
Mega
规划模型。
projects are too large to build at
对，我们要
once.
讨论如何最大化
Engineers
这些
divide
空间。
them into sections, modules, segments. For bridges, concrete sections are built in factories. Each segment is transported and assembled like giant puzzle pieces. For railways, tunnels, tracks, power systems, and stations are built in parallel. For skyscrapers, floors are constructed layer by layer. Structural cores rise first, followed by outer shells. This method saves years of time and reduces risk. At the construction site, engineers become conductors of a massive orchestra. They manage hundreds of machines, thousands of workers, 24-hour shift cycles, using tablets instead of paper plans, AI scheduling software, real-time sensor data. If weather changes, plans update instantly. If a machine detects abnormal stress, engineers receive alerts immediately. Nothing stops moving. Chinese engineers often work where construction should be impossible. In the mountains, materials
foundation
are
stress
lifted by
is spiking
cable
here,
cranes.
adjusting the
Workers
rebar
wear
density now.
safety harnesses at all
Weather's
times.
changing, we need to
Wind
update.
speed
Done, the
determines
model is
work
adjusting.
schedules.
Check for stress
Under
points.
the sea,
Flagged here,
tunnel
we must
sections
reinforce.
are sealed and floated. Precision sinking systems lower them into position. Engineers monitor pressure and alignment in real time. At extreme heights, oxygen levels are monitored, wind speed controls crane movement, robotic systems replace humans where danger is highest. Safety is engineered, not assumed. Before the
AI,
public
check
ever
the full
uses
project.
these projects,
Initiating full scan.
engineers
Overlay
test
the
them
scan results.
relentlessly.
All clear, no
Trains
issues.
are run at maximum speed for months. Bridges are loaded with vehicles far heavier than normal traffic. Skyscrapers are shaken using vibration systems. Sensors record movement, stress, temperature, noise, long-term fatigue. Only when data confirms safety do engineers approve opening. The future is still under construction. If you enjoy this video, please support us by subscribing to this channel and like video and share comment. Turn on your notification for more videos like this.